Assalamualaikum warahmatullahi wabarakatuh. Well, hello people, we are from group 5. This is our mind map task. Artificial Intelligence Application in Robotics.
Robotic and Artificial Intelligence. A. Perspective and Deliberation Function. Monitoring. The monitoring function is in charge of detecting discrepancies between prediction and observation, classifying these discrepancies and discovering from them. Monitoring has at least to monitor the planner's prediction supporting the current plan, although monitoring functions are clearly distinct from action, refinement, and control functions. In many cases, the two are implemented by the same process with a single representation.
Monitoring, diagnosis, and recovery. Diagnosis and recovery are critical in applications like this one crop, for which FDIR, a comprehensive monitoring system, has been developed. Diagnosis and recovery functions. Such systems are usually limited and ad hoc.
For example, the spacecraft is modeled as a fine-grained collection of components. Example given at thrust 14 volts. Each component is described by a graph where nodes are the normal functioning states or failure states of that component. The models of all components are computationally assembled into a system allowing for concurrent transition compatible with constraints and preconditions.
Two query modes are used. 1. Diagnosis IA. Find most likely transition consistent with the observation. And 2. Recovery IA. Find minimal cost command that restore the system into nominal stage. However, it is quite specific to cases where monitoring can be focused on the robot itself, not on the environment, and variability is a critical design issue addressed through redundant component permitting complex diagnosis and allowing for recovery action. It can be qualified as a robust proprioceptive monitoring approach.
Robotics and Monitoring System. Other robotics monitoring systems are characterized into three classes, such as analytical approach, data-driven approach, and knowledge-based approach. Data-driven approach rely on statistical clustering methods for analyzing training data of normal and failure cases, and pattern recognition techniques for diagnosis. This classification of almost 90 different contributions to monitoring in robotics is inspired from the field of industrial control, where monitoring is a well-studied issue. However, the relationship between monitoring, planning, and acting wasn't a major concern in the surveyed contribution.
Monitoring extended logical specification. The idea of using extended logical specification for planning and monitoring has been explored by several other authors in different settings. An interesting variant is for a hybrid architecture, combining a behavior-based reactive control with model-based deliberation capabilities. At each cycle, concurrent active behaviors are combined into low-level controls.
At a higher level, properties of the robot behavior are modeled using linear temporal logic, or LTL. LTL formula express correctness statements, execution progress conditions, as well as goals. The trace of the robot execution observed or predicted at planning time is incrementally checked for satisfied and violate LTL formula.
Temporal Action Logics or TAL. Planning relies of TAL planner, a forward chaining planner using the temporal action logics formalism for specifying planning operators and domain knowledge. The TAL-based system produces plans with concurrent and derivative actions together with conditions to be monitored during execution. These conditions are exist and evaluated online at the right moment using formula progression techniques. When action don't achieve their desired results, or when some other condition fail, a recovery through a planned repair phase is triggered. However, the lack of flexible action refinement is compensated for by specifying planning operators and hence plan steps at a low level of granularity.